Welcome, friends and fellow travelers, to an epic voyage through the vast cosmic ocean of time and space. Our journey, to trace the grand narrative of the universe from its fiery genesis to this very moment, perched here on our cosmic oasis, Earth. We begin, as all stories do, at the beginning. A time when the cosmos we know, a tapestry of stars, galaxies, and planets, was but a whisper in the fabric of existence. Our story is one told by the universe itself, written in the language of light, gravity, and the fundamental laws of nature. From the smallest particles to the largest structures, we'll witness the awe-inspiring events that have shaped our universe. We'll explore the scientific triumphs that have illuminated our understanding of the cosmos, revealing a story more profound and wondrous than any myth or legend. So, fasten your seatbelts and prepare to journey through time and space. Our exploration of the universe, our cosmic address, is about to begin. Imagine, if you will, a universe compressed to an infinitesimal point, smaller than even the tiniest subatomic particle. This, my friends, is the singularity, the seed of all that is, was, and ever will be. Here, all of space and time were once confined, a cosmic soup of unimaginable density and heat. Then, 13.8 billion years ago, this singularity erupted in an event we call the Big Bang. It wasn't an explosion in the conventional sense like a detonating bomb, but rather a rapid expansion and unfurling of space and time itself. In those first fleeting fractions of a second, the universe underwent a period of exponential expansion known as cosmic inflation. Picture a grain of sand suddenly ballooning to encompass the observable universe. That's inflation for you. As the universe expanded, it cooled, and the primordial energy began to condense into matter and the fundamental forces that govern our cosmos. Gravity, the architect of stars and galaxies; electromagnetism, the force behind light and all electromagnetic radiation; and the strong and weak nuclear forces, holding sway within the hearts of atoms. Think of these forces as the cosmic chefs, each playing a crucial role in the grand recipe of the universe. Gravity, the master sculptor, began to draw matter together, laying the groundwork for the structures that would eventually populate the cosmos. Electromagnetism, with its dance of attraction and repulsion, governed the interactions of charged particles, paving the way for the formation of atoms and molecules. And the strong and weak nuclear forces, operating at the smallest scales, determined the stability of atomic nuclei, the very building blocks of matter. These forces, woven into the fabric of the universe from the very beginning, continue to orchestrate the cosmic symphony we observe today. They are the invisible conductors of the cosmic orchestra, guiding the evolution of stars, galaxies, and even life itself. The Big Bang was not simply an event of destruction, but rather a moment of creation, a cosmic seed from which everything we see around us has sprung. The universe, a rapidly expanding cauldron of energy, began to cool. This cooling led to the formation of quark-gluon plasma. Quarks and gluons, the building blocks of matter, buzzed with energy. Held together by gluons, they clumped in a chaotic dance. As the universe cooled, the quark-gluon plasma faded, giving way to familiar particles. As the universe cooled further, the quarks, bound by the strong force, settled into more stable configurations, forming the familiar protons and neutrons. These particles, the very building blocks of atomic nuclei, emerged from the cooling quark-gluon plasma, ready to shape the cosmos. Alongside them, electrons, those negatively charged particles that whiz around atomic nuclei, materialized from the universe's cooling energy. And let's not forget the neutrinos, those ghostly particles that barely interact with matter, zipping through the cosmos at near the speed of light. The universe was now a sea of fundamental particles: protons, neutrons, electrons, and neutrinos, the ingredients for atoms, stars, and galaxies. But the universe was still young, and the journey towards the complex structures we observe today had just begun. From the chaos of the quark-gluon plasma emerged the building blocks of our universe. It's a testament to the elegance and power of the laws of physics, shaping order from chaos, creating the very matter that makes up you, me, and everything we see in the cosmos. The universe, moments after its birth, was a chaotic and unimaginably hot place. but like a cooling ember from a once raging fire, the universe began to cool. As the temperature dropped, the fundamental forces of nature began to shape the cosmos. Around 380,000 years after the Big Bang, a remarkable transformation occurred. Protons and electrons, the building blocks of atoms, began to combine. Light, once scattered, could now travel freely. This era, known as the era of recombination, marked a pivotal turning point. As temperatures fell, protons captured electrons, forming hydrogen atoms. Light finally broke free, and the universe became transparent. The moment those first hydrogen atoms formed, photons, the particles of light, were released. They began to stream across the universe, carrying a faint whisper of the Big Bang. These photons have journeyed for over 13 billion years. As the universe expanded, they stretched, shifting into the cool embrace of microwaves. Today we detect this afterglow as the cosmic microwave background radiation. It permeates the universe from every direction, a testament to the fiery birth of the cosmos. With the birth of the first atoms and the release of the cosmic microwave background, the universe entered a new phase, a period of darkness that would last for hundreds of millions of years. This era, aptly named the Dark Ages, was a time of profound change, a period of gestation before the first stars ignited and flooded the universe with their brilliant light. During the Dark Ages, the seeds of cosmic structure were sown. Gravity pulled matter together within vast clouds of hydrogen and dark matter. These colossal clouds birthed galaxies, the cosmic islands of stars. Smaller clumps collapsed, increasing density and temperature. These collapsing pockets were precursors to stars. Star formation was complex. Hydrogen gas resisted gravity. Dark matter tipped the balance. It provided the gravitational kick needed. Deep within the cold, dark clouds of hydrogen, a momentous transformation was about to occur. Gravity, the master sculptor, drew matter together, setting the stage for the first stars. These first stars, population 3 stars, were colossal and blazed intensely. They burned quickly and exploded as powerful supernovae. In their short lives, they seeded the universe with heavy elements and intense radiation. Their light ended the cosmic dark ages, illuminating the universe. As the first stars ignited across the cosmos, they began to cluster together, drawn by their mutual gravitational attraction. These stellar clusters, bound together by gravity, were the seeds of galaxies, the vast islands of stars that grace the universe today. In the early universe, a giant was born, our Milky Way galaxy. A vast cloud of gas and dust coalesced under gravity. It spun faster, flattening into a disk. Stars ignited, illuminating the nebula. Over billions of years it evolved into our spiral galaxy. The Milky Way, a barred spiral galaxy, is one of trillions. Within the Milky Way, a continuous dance of creation and destruction unfolds. In the spiral arms where gas and dust are most abundant, new stars are constantly being born. These stellar nurseries, illuminated by the intense radiation of young hot stars, paint the galaxy with vibrant hues of red, blue, and gold. As stars age, they burn through their nuclear fuel and eventually reach the end of their lives. Some stars, like our own sun, will end their days as white dwarfs, slowly cooling over billions of years. Others, more massive, will explode as supernovas, scattering their enriched material back into the interstellar medium. This cosmic recycling process, driven by the life cycles of stars, ensures that the Milky Way remains a vibrant and dynamic galaxy, constantly evolving and changing over cosmic timescales. The heavy elements forged in the hearts of stars become the building blocks for new generations of stars, planets, and even life. We are, after all, stardust, connected to the cosmos through an intricate web of cosmic events that stretches back to the very beginning of time. About 4.6 billion years ago, in a relatively unremarkable corner of the Milky Way, a molecular cloud, a cold, dense clump of gas and dust, began to collapse under its own gravity. This cloud, perhaps nudged by the shock wave of a nearby supernova, contracted and heated up, eventually reaching temperatures and pressures sufficient to ignite nuclear fusion at its core. a star was born, our sun. Initially, the young sun was surrounded by a swirling disk of leftover material, a chaotic mix of gas, dust, and icy particles. This protoplanetary disk, a cosmic construction site, held the seeds of all the planets, moons, and asteroids that make up our solar system. Within this swirling disk, particles began to clump together, drawn by their mutual gravitational attraction. These clumps, called planetesimals, grew larger over time, accreting more and more material from the surrounding disk. As the planetesimals grew, their gravitational pull increased, allowing them to sweep up even more material and clear out gaps in the protoplanetary disk. Closer to the Sun, rocky planetesimals formed Mercury, Venus, Earth, and Mars. These small, dense planets are composed of rock and metal. Beyond the frost line, gas giants like Jupiter and Saturn formed. In the Kuiper Belt, icy planetesimals formed comets and dwarf planets. The solar system transformed into an ordered system with planets orbiting the Sun. Our journey through the universe's epic timeline has brought us to a pivotal moment, roughly 3.8 billion years ago. Picture, if you will, a young Earth still reeling from its fiery formation, its surface a chaotic mix of volcanic activity and primordial oceans. It seems impossible to imagine, but it was within this seemingly inhospitable environment that the seeds of life were sown. From the building blocks of the universe, forged in the hearts of long-dead stars, arose the intricate chemistry that would give rise to the first single-celled organisms. These pioneering life forms, known as prokaryotes, were incredibly simple compared to the complexity of life as we know it today. Yet they possessed the spark of life, the ability to replicate and evolve, passing on information through the language of DNA, a code as elegant as the laws that govern the cosmos itself. Their emergence, from the non-living to the living, remains one of science's most compelling mysteries, a testament to the universe's remarkable capacity for self-organization and complexity. Life, once ignited, proved remarkably tenacious. Over eons, these early organisms spread throughout Earth's primordial oceans, their evolution driven by the relentless engine of natural selection. Each generation, though infinitesimally small, brought subtle changes, adaptations that favored survival and reproduction. From these humble beginnings, life diversified, branching out into countless forms, each a unique experiment in the grand laboratory of evolution. The tree of life, with its roots in those early single-celled ancestors, began to grow, its branches reaching out in countless directions. As photosynthetic organisms emerged, they harnessed the power of the sun, releasing oxygen into the atmosphere and forever changing the destiny of our planet. This, in turn, paved the way for the evolution of oxygen-breathing organisms, creatures that would ultimately inherit the Earth. The journey from those first, tentative steps of life to the intricate web of ecosystems we see today is a testament to the power of time and evolution, a process that continues to shape life on our planet even now. Here we stand, billions of years after the Big Bang, in a galaxy we call the Milky Way. The universe isn't static, it's dynamic, ever-changing, driven by forces we are only beginning to comprehend. The expansion continues, accelerated by dark energy. The fate of the universe hangs in the balance. The future of the universe is a topic of great fascination and debate, even among those of us who spend our lives studying the cosmos. Will the universe continue to expand forever, its energy dissipating into an eventual big freeze? Or will gravity eventually win out, pulling everything back together in a cataclysmic big crunch, a mirror image of the Big Bang that started it all? And then there's the possibility of the Big Rip, where dark energy's influence grows so strong that it tears apart galaxies, stars, and even the very fabric of space-time. These potential endings, while based on our current understanding of physics, remain highly speculative. The universe has a knack for surprising us, for defying expectations and revealing new layers of complexity. Who knows what incredible discoveries await us in the future? What new physics we might uncover that will rewrite our understanding of the cosmos? One thing is certain: the universe, much like the human thirst for knowledge, is filled with endless possibilities. As we conclude our exploration of the universe, from its fiery birth to its ever-evolving present, we are left with a sense of awe and wonder. The sheer scale of the cosmos, the elegance of its laws, and the remarkable journey of life on Earth all point to a universe filled with endless fascination. But this is not the end, my friends. Consider this a mere stepping stone in your own cosmic journey. There are countless mysteries yet to unravel, countless questions waiting to be asked and answered. Keep looking up, keep asking questions, and never lose your sense of wonder. For the universe, much like the pursuit of knowledge, is a journey without end, a grand adventure waiting to be explored. Don't forget to subscribe for more fascinating content about our incredible universe. Thank you for watching. Peace and love to all.